of the Always Believe House. Ho, 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 ho. Today we're going to have a rock and roll fun time because we're going to do application problems with quadratics. Wow. Did you know that if you throw a football, it goes in the shape of a parabola? Oh, yes it does. If you hit a baseball, the flight of that baseball is in a parabola. Oh, if you hit a golf ball, the golf ball is in the... All of that involves quadratics, and using what you're going to learn today, you can calculate how far something will go, how high it will be. So we're going to work all of this out. So a magical whiteboard appears. You have what's in front of you. Hopefully you got this printed out. And this is going to be F-U-N, fun, fun, fun. Now then, the key on this is this formula. The V is the initial velocity. For example, if you kick a soccer ball, the faster your foot is moving, the further the soccer ball will go. The initial velocity is how fast your foot is moving when it hits the ball. The same thing hitting a baseball. The faster you can get your baseball bat and the faster the ball moving in, the faster that baseball bat goes, the further the ball will go if it's hit in the sweet spot, right? Golf ball, the faster you swing the golf club, the further the ball will go, okay? That's the initial velocity. The H is the initial height. For instance, if you kick, let's say you punt a soccer ball. When you kick the soccer ball, it might be 2 foot off of the ground. That's the initial velocity. If you hit a golf ball and it's on the ground, the initial height will be 0 on it. So when we read through this negative 16t squared, that negative 16 is basically the force of gravity on the Earth. If you were to go to Mars or the Moon, that negative 16 would change, okay? So basically, you're going to do negative 16, and you're going to have to use x on the calculator, but let's use t squared, and then plus... You're going to put the initial velocity here, and then plus the initial height here, okay? Piece of cake. Now then, this worksheet does not have everything I'm going to do for you. We're going to probably do 2 together, and you're going to repeat the process all the way down, okay? So let's look at number 1. Okay? An object is launched directly upward at 64 feet per second. That is the initial velocity, or V0. The 0 stands for 0 seconds, okay? From a platform 80 foot high, that's my initial height, or the height at 0. What will the object's maximum height be? When will it attain this height? How long will it take for the object to reach the ground, okay? So let's make the equation first. So let's write down h of t equals negative 16t squared and plus 64t and then plus 80. Okay, now then on every single problem to the right, put the equation right in the middle, and then to the right, make a first quadrant graph. This will be feet. This will be, let's see, seconds, right? Yeah. This will be seconds, and the height will be feet, okay? The y will be feet. This is going to graph a parabola. It's going to go up and down. So all of these problems are going to have similar parabolas, okay? So let's go to your calculator, hit the home button, and let's do a graph B. Okay, I'm going to hit menu 3-1, menu, graph, and then function. We always want to graph a function in Algebra 1, and it should say f1x. If it doesn't, menu 3-1, boom, you get your f1x. Now then, it's negative 16, we have to use x, squared, and then plus 64t plus 80. Plus 64x plus 80. Okay, so I have it in. I don't know why my x's are capitalized. I'll fix that later. Yours can be little. It's not going to make a difference. Hit enter. Now then, we can't see the whole parabola because it's zoomed out. Remember, our y-intercept's at 80. So what we're going to do is graph trace. And we're going to get 3 important dots on this graph. So hit menu, graph trace, remember, is trace, and then graph trace is 1, menu 51, and it starts off at the y-intercept, which is 0, 80. Now then, let's hit the right arrow button and get to the top. So hit the right arrow button until the top will be the maximum on it. Okay, so the maximum is going to be 144. At 2 seconds, it's at 144. So we're going to go to the paper, we're going to put a dot here, and that's 80. Let me do this in a different color. So put a dot here and put 80. Then it goes up and then back down. This dot right here was 144, 144. Which is the maximum height in it. Okay, and that occurred at 2 seconds. Then let's trace down, and the next important dot is this. That's when the rocket hits the ground, okay? So go back to the graph, and we're going to go, that's basically the 0 of the function in it. So we're going to go down until that y is 0. Don't hit it a whole bunch because it'll switch. There it is at 5. So at 5 seconds, it hits the ground. This is 5, 0. Okay, some very important numbers here, okay? So what will be the object's maximum height? Put max height equals 144. When will it attain this height? At 2 seconds. How long will it take the object to reach the ground? 5 seconds equals hitting ground. Now then, I want you to write down the domain and the range for every graph, okay? And look at this graph. The domain goes from here to here, which is 0 to 5 in it. So your domain is 0 less than or equal to x less than or equal to 5, right? The range, remember, you go from the bottom to the top. The range, and let me do this in green, the range will go from here, which is 0, up to here, which is 144. So the range is going to go from the ground up to 144, right? Because it doesn't have the 80 in it, does it? It goes up to the 144, then it goes all the way back down to 0. So the range value is 0 to 144. Okay, 0 less than or equal to y less than or equal to 144. So you're going to answer the equation on all of them. Make sure your graph has this every single time. You're going to have the y-intercept, the maximum height, and when it hits the ground. Then answer the question, okay? Sometimes it may want to know the height at 2 seconds. So you'll go and trace to 2 and write that down, okay? Like on the next one, okay? Let's go to number 2. Okay? On number 2, first thing you're going to do is write down the equation. So I think we're using h of t. So the function of time equals negative 16 t squared plus, and the initial velocity is 80, so plus 80 t, and then from the ground, so plus 0, okay? So it's not fired off from a platform. Now then, when we punch this in the calculator, we won't need the 0, will we? Now then, let's go over here to the right. We're going to draw our graph, and it's going to get fired from here, and the graph's going to go up and down. I need to find this dot and this dot, don't I? So I know this dot's at 0. I'm going to trace to that up one, and if you read it, find the highest point reached by the projectile, and then how high will it be after 2 seconds? So I need the 2 comma something, right? So I'm going to find all of these, answer the questions, and write down the domain and range. So let's go to the calculator, delete, delete, delete. That gets rid of my graph, then hit tab, and then negative 16 x squared, and then it's plus 80x, plus 80x. That's all I got to put in. I don't put the plus 0, do I? Hit enter. This graph should start off on the y-axis at the origin, right? Because there's no c. So hit enter, and boom, it's right there. Now then, menu 5.1. So menu 5.1, that starts graph trace, and I'm going to trace to the up. Okay, so hit the right arrow button until it says maximum, right? Don't hit too many or it'll go past and you got to wait for the calculator to go. right there. So the maximum is at 2.5 comma 100. Okay, so I'm going to go to my picture, draw an arrow here, 2.5 comma 100. And now I need to find this dot, don't I? So I'm going to go back to the calculator, and it should be at 5 seconds. It's going to hit the 0, okay? So keep hitting the right arrow button. Do not hit the up or down button. And at 5 it is 0 in it. Okay? So at 5 it's 0 again. Now then, read the questions. Find the highest point reached by the projectile. The highest point equals 100 feet. That's your maximum height in it. Now then, we need to calculate 2 seconds. So 2 seconds equals, so go back to your calculator. We're still in trace, right? Hit 2 and enter. So 2, notice the 2 pops up, enter, and it's going to go straight to 2. At 2 seconds, it's at 96 feet in it. So go down to here, 2 seconds equals 96 feet. I've answered all my questions, right? Now I'm going to get my domain and range. So the domain is going to go from 0 to 5, right? The range is going to be my y's. Let's do this in green. It's going to go from 0 all the way up to 100 in it. So the range goes from 0 to 100, okay? Piece of cake. Oh, ho, 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 ho. Let me read through these to make sure none of this is going to change. Okay, let's go to number 6. This is a little bit different, okay? Because this is area, okay? So number 6 is a little bit different. Okay, on number 6, you're on number 2, 3, 4, 5, 3, 4, 5, you're going to repeat the process. Make sure you answer the domain and range for every one of them. Get the initial y-intercept, get the maximum height, and when it hits the ground again, okay? On this one right here, the pad's length is 12 foot longer than its width, and the area is 864. Find the dimensions of the pad. This is a little tedious, okay? So draw a rectangle, and then you want to figure out which one's the smallest, okay? The length is 12 foot longer than the width. The width is smaller in it. So let's put W and W, and the length is 12 foot more than the width. So put W plus 12. And the area is 864. So length times width equals area, right? Length times width equals area. So the length is going to be W plus 12. The width is going to be W, and the area is going to be 864. Ho, 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 ho. Now then, multiply by the W. So distribute the W. So W squared plus 12W equals 864. And then we're going to move the 864 over. So W squared plus 12W minus 864 equals 0. Now then, we're going to factor this and get the zeros, okay? You could graph this and trace to the positive 0. We're going to factor it though, and we got to use 864, subtract, get 12. So go to your calculator, delete, 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 hit enter, and then we're going to graph, hit tab, 864 divided by x. Hit enter, and now then we're going to hit Control T. Now then, this is going to take a while. We need to subtract and get 12. So we're going to keep hitting the down button until the number subtracted give us 12. Right there, 24 and 36. So at 24 and 36, I subtract and get 12 done. So I'm going to go back to the calculator. I'm going to draw my parentheses. Write down W and W. This sign drops. This will be negative. And it's going to be 36 and 24. The big number goes here. The small number goes here. Now then, remember, these are the factors. And the zeros are opposites, right? So the zeros are going to be negative 36 and positive 24. This right here is going to be my W. And if I do 24 plus 12, I get what? 30 what? 36. So the dimensions are 24 and 36. Okay, so you're going to do length times width. You're going to set it equal, factor it, and get that answer, okay? Remember, you could graph this and trace to the 0. You would go to the positive 0, wouldn't you? That would work. I would not take off if you did that. Let's set up number 7. I'm going to set these next two up and let you solve them because this is kind of tricky. Okay, Ethan made a wall and broke the window. The length of the window right here. Okay, the window had an area of 960. The length of the window is 8 inches less than twice the width. That's kind of tricky. So let's write this down. Here's the window. The length of the window. The length of the window was or is 8 less than, and you got to flip, so twice the width. Okay, so the length is 2w minus 8, and here's our width, okay? So if I multiply those, I get 960. So I'm going to distribute the w, 2w squared minus 8w, move the 960 over, equals 0. You need to get the factors of that, okay? Or you could graph it and trace, either way. So you need to solve that on your own. Let's go to number 8. The mural's width is this. So the width equals, and then less than, you got to flip, then the height. Okay, we'll put h. So let's draw this. So the width is 6 meters less than the height. So what we're going to do is we're going to put height, and then the width is h minus 6 in it. Okay, so we're going to have h times h minus 6 equals 1512. We're going to distribute the h squared minus 6h, move the 1512 over, equals 0. Now then, I hope you're listening right now because I'm about to show you a cool trick. I'm going to show you how the calculator can calculate and get the roots, okay? What we need are the zeros, right? One's probably going to be negative, one's going to be positive. We are going to want the positive 0. This is how the calculator can get the zeros, okay? So remember, this is 1, right? So 1, negative 6, and 15 are my numbers in my polynomial. So go to your calculator, hit the home button, go to calculate, the scratch pad, and now then hit menu. Now then, algebra is 3. Polynomial tools is 3. You might want to write this down. Find the roots of a polynomial is 1. Now then, don't ever change this in Algebra 1. In Algebra 2 you will hit enter. And then, do y'all see the A2, A1, A0? That's the A, B, and C. AX squared plus BX plus C. So I have 1, negative 6, and negative 1512. 1, down, negative 6, down, negative 1512, down, and then hit enter. Now then, this should be the equation we want. It is. So hit enter again, and shazam. Those are the zeros, negative 36 and 42. So go up to your calculator, write down x equals negative 36 and 42, right? Is that correct? Yep. Can I have a negative? I can't use the negative, so the h is going to equal to the 42. And 42 minus 6 equals 36. Okay, so find the height. The height is going to be equal to 42. Ho, 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 ho. I'm only going to show you that once. So like you could do this one with that trick I just told you. Okay, go back and look at the directions for that, okay? I'm only going to do that once. I really shouldn't have done that. Okay, have a wonderful, wonderful day. You learned about application problems with quadratics. It's really cool. When you hit a golf ball, when you kick a soccer ball, a football, this holds true, okay? Make sure you're drawing that parabola on all of these problems and make this picture, okay? So you're going to draw the vertex, the y-intercept, and the 0, and possibly find out how high it is at 3 seconds. and you always use the negative 16t squared plus the initial velocity plus the starting height. Have a wonderful, wonderful day. Remember, you are amazing, you are created to do wonderful things, and you are awesome.